Hi everybody, welcome to this AP Computer Science review video where we're going to look at some solutions to these 5 problems that were posed to us recently. First we were asked to set up 3 string variables. You can do it how you want. This is how I did it. I decided to call mine N1, N2 and N3 just to reduce my typing. And I've assigned them some values, Jack, Jill and James. I now have 3 string objects. Alright, the first problem was to write a program that will determine how many of the string objects store the name Jack. Well, in this example, the answer is 1. So let me share with you my solution. I first created an integer variable to store the result of the program, and I set the value to 0 at the beginning of the program. I then created an if statement. If n1 equals Jack, count plus plus. So if n1 equals Jack, we're going to increment the count. Let's just take those 2 lines of code and just paste them out. And we'll have n2 and n3. So if n1 equals Jack, count plus plus. If n2 equals Jack, count plus plus. If n3 equals Jack, count plus plus. Brilliant. System.out.print count. And if we run that, hopefully the answer will be 1. And there it is. Because this meant that this is true, so 0 became 1. N2 does not equal Jack, and N3 does not equal Jack. So the count was not incremented in those 2 situations. Alright, let's go on to the next problem. Write a program that will determine how many of the string objects, so again we've got how many of the string objects store a name of length 4. If n1 dot length, let's use the length method, is the same as 4. If n1 dot length equals 4, count plus plus. And let's just copy and paste that. So note that n1 dot length will give us a number, and the number will be an integer. So we can use the double equals sign to do the comparison. And the answer is 2, because Jack has a length of 4, Jill has a length of 4, and James does not have a length of 4. But if we change James's name to be Jame, which is a rather unusual name, we should get the answer of 3. Alright, let's just change that to be James again, and we'll move on to the next problem. Write a program that will find any names which are Jack and change them to Jackson. Ooh. So let's just do Control Z, 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 Z. We'll go back to our equals Jack code. If n1 is equal to Jack, then let's just change the value of n1, or the string that n1 points to. n1 becomes equal to, let's do new string Jackson. And let's just remove this code for a minute. Okay, let's just copy and paste. What the heck? Got no idea if this is going to work at the moment, but okay. If n1 equals Jack, it will become a new string which is Jackson. If n2 equals Jack, n2 will become a new string which is equal to Jackson. And if n3 is equal to Jack, then we will construct a new string and assign that to the n3 pointer. And system.out.print, let's just print out everything. n1 plus a space plus n2 plus a space plus n3. So we're just going to print out the 3 strings in one line. Hopefully we will see Well, if n1 equals Jack, yes it does. So it will change n1 to be Jackson. And that's the only change, isn't it? So we're going to see Jackson, Jill, and James. Jackson, Jill, and James. Now I'm just going to do one little thing here. I'm going to change James to Jack. And I'm going to change, this is N3, I'm going to change the N3 code to N3 equals Jackson. Can I do that? Is that another way of assigning a new string to a string pointer? Well, let's have a look. Yes, that works fine as well. So it's really up to you how you want to create your new string and assign it to a string pointer. And remember that N3 is a string pointer. Okay? Alright, let's move on. Write a program that will find the longest name and display the name. Ooh, that's tricky, isn't it? Write a program that will find the longest name and display the name. Oh my goodness. Let's get rid of all this junk. Let's start again. This is tricky. How do we do that? Let's change this Jack back to James while I'm thinking. There are loads of ways to do it. I'm going to do it the long way, people. I'm sorry about this, but this is just the way I'm going to do it. Let's create an integer variable called n1 length, and that's going to be equal to n1 dot length. So this variable will be assigned the length of n1, which is 1, 2, 3, 4. And let's copy that. Control V, Control V. This is going to be an integer variable called n2 length. And here we will have an integer variable called n3 length, which will be assigned the length of n3. If n1 length is greater than n2 length and n1 length is greater than n3 length, it means that n1 is the longest. So I'm going to do system.out.print n1. And let's just copy that code and paste it. We'll just line it all up so it's readable. Brilliant. So if n2 length is greater than n1 length and n2 length is greater than n3 length, we're going to print out n2. And if n3 length is greater than n1 length and n3 length is greater than n2 length, it means that n3 is the longest. So hopefully we're going to see James as the result. Bingo. Notice this is a very long way of solving this problem. However, it solves the problem. So as long as it's within reason and you're not having to write 50 or 60 lines of code for a short answer, it's reasonable. Of course, there are many other ways to solve this problem. Okay, let's move on to the final one. Write a program that will find any names with a second letter which is A. Write a program that will find any names with a second letter which is A and change it to @. Note, you will have to investigate the substring method of the string family. Oh my goodness. Alright, let's start at the beginning. So at the moment, I'm not going to worry about n2 and n3. I'm going to see if I can solve this puzzle just for one string. We're just going to look at n1. I'm going to make a new string called Ooh, what do we want to do here? We want to change that A to an @ mark. So I want to keep the J, I want to keep the C and the K, but I want to change the A. Oh. I want to keep the J. String start is equal to n1 dot substring. String start equals n1 dot substring 0, 1. That will give me a J. And just to prove that, let's do a system.out.print start. This start here. Let's just run that. There's the J. I've managed to isolate the J into a string variable called start. Brilliant. Let's just get rid of that for a minute. I'm just going to comment that out. String end. So I just want to take away the C and the K. Well, this is index, for the substring method, this is index 0, this is index 1, and the C is index 2. And I want to take everything after that index. So string end is equal to n1 dot substring 2. So this will go to index 2, and I didn't tell it when to stop, so it will take everything. And to prove that, let's uncomment that and type in end. And we'll just run that. Hopefully we'll see CK. Brilliant! So I've got a J and I've got a CK. Now I just need to find out if the second letter is an @ mark. If n1 dot substring, what's the second letter? 0, 1. It starts at 1 and it stops at 2. If substring, if n1 dot substring 1, 2 dot equals A, string middle will be equal to an @ mark. Else string, I'll tell you what, let's initialize middle outside of this if statement. I'm going to initialize middle up here. String middle. If n1 dot substring, the second character equals A, middle will be equal to an @ mark. Else middle will be equal to an A. And now I'm going to rebuild n1. n1 will be equal to start plus middle plus end. And let's do system.out.print n1. I've rebuilt n1. And now we're going to display the result. What have I done wrong? There. No semicolon. We'll run it again. Jack! So take a look at that code, everyone, and see if you can figure out how that works. And look at the result.